Okay, ladies and gentlemen, what we're going to be doing this afternoon is we are going to be looking at similarity. Now, what does similarity mean? Similarity means that two objects share characteristics. Similarity does not mean that they are identical. Does not mean identical. It can, but it doesn't mean that they have to be identical. Identical. What similarity means is it means that they're proportional. So similarity is proportional. They're an enlargement or a reduction of something that is essentially the same shape. When things are similar, they have equal corresponding angles. And the length of the sides are proportional. Now again, I'm going to use a bunch of symbols here because I'm not going to be able to draw things that look exactly alike. So please bear with me if things do not look as pretty as they could. But let's say we have a shape something like this. I'm going to tidy that up a little bit. Actually, let's do it this way. Now, if I look at these two shapes, do these two shapes look similar? They do look similar. Well, you just watch me make them, so it's pretty obvious that they're similar. They're in fact identical. They're just scaled differently. But in order for them to be considered truly equal, the following things have to be true. Now I'm going to label this diagram. I'm going to label it A, B, C, D, E. And then I'm going to label this one Q, R, S, T, V. So there's our two polygons, A, B, C, D, E, Q, R, S, T, V. In order for these to be similar, the sides, all the angles have to be identical. So I'm going to indicate that. So this angle and this angle are the same, or I can identify that by a symbol. So why don't I just use a little symbol there? I'm going to put what shape? Let's just put a dot in there. Those are the same. Whoops. Those are the same. Those are the same. Those are the same. And well, may as well make that a right triangle. So that shows that all my angles, I've now indicated through my diagram that all my angles are identical. That almost makes it proportional. The other thing, similar. Similar and proportional are two terms that can be used interchangeably. The other thing that needs to happen for this to be similar is I need to show that my sides are proportional. So let's say that AE is 7 centimeters and ED is 11 centimeters. And I say that BQ is 21 centimeters. And I say that VT is 33 centimeters. is this proportional? Well, how we find it out, what we're going to do is we're going to set up a proportion. And a proportion is two fractions in an equality to compare things together. So the first thing we're going to do here is we're going to have, so let's call this shape, this one is shape alpha, this is shape beta, or let me think, no, that's quite complicated. So we have, for this to be true, line AE over line BQ needs to be the same proportion as line ED over line VT. Now this part, sometimes people get a little bit confused. So what I'm looking at here let me use that pen. Interesting. What I'm looking at here is this line and this line being proportional, and this line being proportional. So if I was to take the larger of these two shapes and rotate it so that it lines up properly, the important thing here is remember corresponding angles. So what I'm going to do here is I'm going to try this. So what this states is 7 over 21 equals 11 over 33. Okay? So how do I figure out if that's proportional? Does anybody remember? What's the most common technique we use in this class? Cross multiplication or cross product. So or in this case, I've totally messed something up. Yes, I have. Whee. Oops. Well, obviously I'm going to have to re-record this session. Totally messed that up. 7 over 11. So it's AE over ED is equal to dq over dt, which is 21 over 33. I'll set this up again with a simpler thing. How do I solve this? Well, I'm just going to determine the cross products. So using my calculator, what's 11 times 21? Is 231. And 7 times 33 is also 231. So 7 times 33 is equal to 11 times 21. So if the cross products are equal, it means they're proportional. One.